Hey guys, Mr. Bowman here. Today's learning objective is in blue. We are learning to identify the angle properties of a triangle's internal angles. So the first thing to focus on, and it's something that may be apparent to most of us, triangles, that word tri stands for 3. And then angles, we know all about those. So basically what this is trying to say is it's a shape with 3 angles. And these shapes, triangles, they are literally everywhere. Everywhere you go, you're going to see some triangles in some shape or form or another. And I've got a few examples. So we can see that half sandwich, that's a triangle coming up in our food. We can see the road sign. So that's triangles coming up when we travel. And even in our recreation, we've got that pool cue. Recreation, we've got that pool cue setting up ready for that game as well. So triangles everywhere, we can't avoid them. And the cool thing about triangles is they've got some really, really interesting angle properties. We're going to start off with the basics today, and that's focusing on the internal angles of each triangle. So I'm going to draw a bit of an example. But the internals, they would be these 3 angles here. There we go. We've got 3 internal angles. And what we know about those angles, all of those angles, they are going to sum or add to 300 degrees. So let's call them angle A, angle B, and angle C. They're going to be equal to 180 degrees. Nearly wrote 360, but definitely 180 degrees. And let's go through a couple of examples of how we can use this information to help us solve problems. Question number 1, let's say we've got a triangle here. Let's say this is a right angle triangle maybe. And we know that this top angle here, let's say that's 50 degrees. We wouldn't have to go ahead and measure angle A because we got enough information to figure that out. So we know that right angle, that's going to be 90 degrees. And we know they're all meant to add up to 180. So we're going to go 180, take away the 90, take away the 50. And that leftover amount is going to be the angle which is equal to. And in our case, 180 minus 90 is 90 degrees. Minus the other 50 is going to be 40 degrees. So we know that A will be equal to 40 degrees. And that's because I'm going to use some abbreviation, internal. And hopefully you can see here I'm drawing a bit of an angle. Angles in a triangle equal 180 degrees. So taking some shortcuts with my justification there. Another example, a fairly similar one. We won't make it a right angle triangle, we'll make it a bigger triangle just up here. So let's say this here, maybe that's 100 degrees, quite a big angle up the top. That there's going to be 50 degrees. What would that angle there, angle X, be? So we know all 3 angles, so the 100, the 50, and the X, all of them have to add to 180 degrees. So what I'm going to do is I'm going to start off with my 180, I'm going to take away the 100, and I'm going to take away the 50. And that equals angle X, or the leftover amount for angle X. So 180 minus 100 is 80, minus another 50 is going to be 30 degrees. So 30. So X is equal to 30 degrees, and that's because the interior angles, so interior angles in a triangle equal 180 degrees. So just noting, I've got my justification. So whenever you're doing a geometry-related question, justifying your answer is really, really important. Another example for us, and this is going to integrate some of the other skills that we've learned. So let's say I've got maybe a big line along here, and I've got a triangle coming off that line, but not all of the lines. You can see I've got a bit of a gap there. And we're going to say, well, this angle here is 120 degrees. This angle here is 70 degrees. Let's say we don't know what this angle is, and we don't know what this angle is. So a lot of us might look at it going, well, I don't know 2 of the 3 angles in the triangle, so I can't figure anything out. But we can actually use this 120 degrees to figure out what A is, and then once we have A, we can then figure out what B is. So I know that angle A and 120 degrees, they're sitting on the straight line underneath it. So they're sitting on that, so they've got to add to 180. So I'm going to go 180, which is the straight line, minus the 120 degrees I know. That should give me the leftover amount for angle A. And that's going to be 60 degrees. 60 degrees, and that's because angles on a straight line they sum to 180 degrees. And so I now know this angle here, 180, and I know all three angles in that triangle are meant to add up to 180 degrees as well. So we want to go 180 minus the 60 degrees, which is angle A we just calculated, minus 70 degrees, which is the top angle we've been given. We can find out what that is. So 180 minus 60 is 120, minus another 70 is 50 degrees. So I know that angle B is equal to 50 degrees, and that's because interior angles of a triangle equal 180 degrees. So a bit more complicated, so I've used some of those straight angle or straight line rules to find out those answers. We can even get a bit messier as well. We'll draw one final example. Let's say we've got a triangle here, or maybe I've drawn another triangle over here. We could calculate this missing angle here in the middle, x, by looking at our triangle. So let's say we don't know that. That's angle A, that's angle B, but we know this angle up the top is 60 degrees, and we know this here is also 60 degrees, and this one here, that's going to be 90 degrees, and this one here is going to be 50 degrees. So I can calculate angle A and B with our triangle rule. So angle A, so 180 minus 60 minus 60, that's equal to 60 degrees. We can do the same for angle B over here. So we know 180 minus the two angles we know. So minus the 90 minus the 50, minus 90 minus 50. That there is going to be equal to 40 degrees. And we know both of those because angles in a triangle sum to 180 degrees. And I've now got these three angles left here. And the cool thing about this is all of these angles sit on that straight line. So I know that A, B, along with X, all of that have to add to 180 degrees. So if we want to calculate angle X, I'm going to go 180 minus angle A, which is 60 degrees, minus angle B, which is 40 degrees, and that gets me to 80 degrees total. And that last one, so these first two were because they were interior angles in a triangle equal 180 degrees. And the last one, angles on a straight line, so I'm using some abbreviations, straight line equals 180 degrees as well. So we're getting pretty messy, but we can see the integration of some of the other rules that we're looking at with our triangle rule. So thank you so much for watching, guys. Hopefully this video made sense. Now let's get into heaps of practice.